Chemistry lessons using and converting metric units. Now the metric system is used in almost every country in the world except for a few, one of those being the United States. Several years ago we tried to switch over. There was a lot of people in businesses that says it's going to cost us too much to convert all of our units and recalibrate our machines. But the biggest problem was the people of the United States could not figure out how much they were paying for gasoline because they were used to looking at it from gallons. Now they had to look at it in liters, and being since we change most of our stuff depending on what the populace wants, they jumped out of this and said, okay, we'll stay with our current system. This has caused many problems over the years because when we work with other countries that use the metric system, which is far easier to use than our system, we end up creating mistakes. There was a multi-million, if not billion-dollar satellite that the European Union and the United States was working on together, and because two of the scientists, one used the metric system, one used our system, transposed the numbers just a little bit and didn't get it exactly right. When the space shuttle set this satellite out into orbit, it immediately plummeted down into the Earth's atmosphere and burned up, which was a very, very expensive lesson. So they now have tremendous computer programs and things of that nature to try to fix this. But in chemistry here, you will have to use the metric system on a continuous basis. We do not use teaspoons, tablespoons, quarts, pints, gallons, things like that. We use things like grams for weight, we use meters for length, and we use liters for liquid measurements. And you'll have to get used to changing them, and once you get used to it, you'll find it to be very simple. Here is a chart that goes through and shows you the metric units and their symbols. Now, in your computers and your phones and stuff, you're already using some of this stuff now. As you can, you hear gigabytes, you hear megabytes, and now in cloud storage and stuff, you hear terabytes. They're also starting to get up into the point of using, petabytes. And then you're also hearing, I need this many milliliters of this or this many microliters, and now we're down into nanotechnology and things of that nature, so very small. So you're in your computers and electronics of all types, they're using the metric system on a common basis. However, in this class, our most common units are going to be micro, milli, centi, deci, kilo, and mega. If you can remember those, you'll get through most all of the stuff that we have to do in this class. Now, the basic way to do this, as I said, is just moving the decimal number. So, when you want to go from one unit to the other, all you do is to just change the decimal, write the number down, and move the decimal in the direction that it says. As it shows right here, we start with the basic unit. Then if we're going to convert to a smaller unit, we would move the decimal in this direction. Okay? So if we said, okay, if I had 1.0 grams, and I wanted to know how many milligrams that equals, then I would write the number down, 1, and then I would say, okay, that's going to be moved how many places? That would be 1, 2, 3 places. So that would be 1, 2, 3 places. So that would equal 1,000 milligrams. Okay? Now let's see if we can't, do some. So as you can see, I want to know how many milliliters are in 500 liters. Now liters is one of the base units, so I don't have to worry about that. And sometimes I see students that it helps them to just make a little line graph, and they can just draw this up here kind of like this. And if they can just remember the different deals, the smaller sides go over here, so here would be deci, okay, centi, and then right here would be milli. Put that other. And over here is something called micro, which is something we also do. So this here would be, moving at 1 place, 2 place, 3 places. The tricky part is between milli and micro, there's 3 more places right here, so this here is 6 places. And if we go to the other direction, you've got your deca, and then hecto, and then the one that we start to use in this class, which is kilo, and then mega. Once again, this is going to be 1, 2, 3, and then this would go up to 6. So I'm going to start here in the middle because that's what my question says. I write down my problem. 500 liters equals how many milliliters? So I want to go from here, and I'm going to go over 1, 2, 3, because that's the symbol for milli. I need to go 3 places. So my decimal normally would be here, but I need to move it 3 places. So I write down my number, 500, and then I move my decimal over 1, 2, 3. So that would be 500,000 milliliters. Or from the lesson we just learned a little bit ago, to put this in scientific notation, would be 5.0 times 10 to the what? 1, 2, 3, 4, 5. Okay? That would be 5 milliliters. And there would be my answer. Let's see if we can. Now we want to say how many milliliters are in 250 microliters. So once again, as I told you, sometimes it helps to just draw this little deal here so you can get an idea of where you're at. Remember, right here in the center is the base. This is the big side and this is the small side. We're not going to write this big side this time because I'm dealing with everything over here on the small side, so we're just going to work on the small side here. Remember, this first one is deci. Then I have centi, which this is to the 10th, or 1, to the 100th, or 2. Then I have milli, which is going to be to the 3rd power. And then I have this little funny symbol, which is called mu, which is micro symbol. And this one here is the 1, 2, 3, and then I said 3 more places, or 10 to the 6th. Just so you can get an idea of what we're doing here. Now, as it says, I want to write down my problem right from the start. I have 250 microliters equals how many milliliters? Okay? So then, I find out where I started with. Right here's where I started with. So I'm starting right at this point on my chart right here. Now, I'm going to go in this direction. So, is that going to be a bigger or smaller number? That's going to be smaller. That's correct. So, I've got 250 microliters, and I'm going to move the decimal back 3 places. 1, 2, 3. So that's going to equal, I always want you to put a 0 in front of the decimal place, so when I don't have to decipher your writing, it's easy for me to tell that you meant that. 250 milliliters. Okay, so that's 0.250 milliliters. Now, you would then write that in scientific notation as 2.5 times 10 to the what? What would you put there? Give you a couple seconds to figure it out. Would that make it a bigger number? Which way am I going to go? I'm going to go the -1, okay, milliliters. And then there's my answer. What you need to make sure that you do is to go over this as many times as necessary and always ask questions in class if you have them. Remember to never, never, never give up and to stay gritty.